Okay, so what we're going to do right here in this one is we're going to show you how to apply cutter comp, and basically we're just going to do the square of this part here. Now this part, if you haven't noticed, these are not inches. This is in metric. Usually you can tell something's by metric as the number of decimal places it's taken out to. There's other ways to do it. Sometimes it's actually marked on the print here. If you see right down here, there's a thing that says metric right there, so that helps you tell it's a metric print. We're just going to show you how to apply cutter comp. It's no different in metric. It's just you're going to do different numbers. So I'm just going to do a simple square. We're going to start off with our x0 and y0 in the lower left hand corner, and we're just going to mill from there to there to there to there. That's all we're going to do. For this particular part, I've decided to use 11 millimeter end mill. Right up here you can see. Okay. And we'll go back over all this one more time. So that's what we're going to do. The idea is that when you get done, you'll be able to apply cutter comp, get a little better idea. This is going to be the first video, then I've got another video you're going to watch after this. Okay, so bottom line, what we've got here, always a percentage sign, always a program number, capital O. The only time you'll use a capital O in the entire program, followed by 4 to 5 digits. Now, our safety line, because we're in metric, has changed a little bit. We're going to put it in rapid. We're still going to cancel any can cycles. We're still going to use absolute coordinates. But right over here, this used to be a G20. A G20 says do it in inches. G21 says we're going to work in metric. You need to put that in there. It won't work without it. G17, again, arcs are going to be performed in the XY plane. Remember, this is the X-axis. This is the Y-axis. Okay, so the G54, we're going to activate our work offsets again. All that means is the machine is going to read where you told it from machine home. You're going to physically tell it the distance from machine home to where you want part X0, Y0. That's going to go in usually some sort of G54 offset page. There's a variety of different ways and controls to do it, but that's what that does. It always needs to be there. Please leave it standalone. I'm going to specify it again. If you don't follow this format right here, one, I'm not going to be able to help you. Two, no machine generated code, people. If you send me something that was obviously generated from a CAD CAM software, I am not going to grade it. You're going to get a 0. I'll give you the opportunity to resubmit, of course, but let's just not do that. This class is not about CAD CAM, okay? Not about CAD CAM. We have CAD CAM classes where we use Mastercam, all right? All right, let's get back to this. Tool change, line in 20 is tool change. I put down what diameter end mill I'm using. And for the sake of that, I'm going to put some other stuff in here. I'm going to put down 4FL, which stands for 4 flute. So may I delete that? Yeah. 11. Let me change this real quick. Here's a bad thing. So you can't drag, or so you just have to. I guess I can just do this. I put that in the wrong place. Yeah. Talking and typing. Try it sometime. It's not that easy. It really isn't. Those people who do it well, I have to admit I'm impressed. All right, there we go. Let me see if I got an extra space here. Looks like I do. Can't tell with Notepad. Control S. There we go. So we do our tool change. We're going to use 11 millimeter for flute end mill. Great. Now I'll calculate up the speed here. This speed is not right. Let's go ahead and do it. I had to rotate this view, so see in the MATLAB. Oh no, you can't see it. Oh God, using a cutting speed of looks like 90. It says using a 7/16 blah blah blah, cutting speed of 90. So let's use cutting speed of 90. Do another RPM calculation. So we take 90 times 3.82 equals this, and you're going to say divided by 11. Well, that won't work. Well, let's try it divided by 11. You're going to come up with a really ridiculously slow number. Yeah, let's run this end mill at 31 revolutions a minute. You see, you can't put millimeters into this formula and expect to get it. So what we do is we have to convert the millimeters to English. So let's bring that back up here. Come on, back up. Clear you out. Clear. So how do you do that? Simple. 11 divided by the magic number 25.4. That is the English equivalent of an 11 millimeter for flute end mill, which that's almost 7/16, 4.4375. So it's 7/16. That's the number we want to use. I'll go ahead and I'm just going to hit memory store, stick that sucker in there. Let's clear it all out. let's start over again. So 90 times the constant 3.82 equals this, divided by memory recall. Right, now this time I'll get my right RPM. Boom, 793. I'll round up to 794. So let's change that right now. 794. Great. Control S if you haven't done that. Now, something else I have put up in one of the modules there, a block numbers. So I've got block numbers already. All you have to do is copy and paste them into your program. It'll save you the time of, you know, putting them in there, because in the face-to-face class we have software that generates these for you. So I give you a little help. I think let me see, I copy and paste these all the way down to 1,000, which I believe is going to equal like by tens. So you have plenty of room there. If you need more, you're going to have to just add more yourself. Get used to that anyway. Okay, remember that again is going to be spindle on clockwise, and that spindle speed is going to be 794. No decimal point, right? Right? Right. Don't put it in there, won't work. Then we're going to activate our tool length offset. Remember the H number. H1 has to, if this is 201, this has got to be H02, excuse me, H02, tool 0. If this was T03, this would have to be H03, etc., etc. All right. So we've got all our, this is your whole program startup. The only thing that we changed this time, of course, is I put in the size of the end mill I was using in metric. I made sure I put a G21 up here instead of a G20. Now, since we are doing metric, some other things have to change. Okay, there's one thing right here that has to change. I'm rapiding my tool length offset down to 1. Now you're going, oh, that was 1 inch. Now it's 1 millimeter. If you do that, you'll that's not good. That's like 25 thousandths of an inch. So seriously, folks, let's just put 25.4. That is an inch. What? Really? Yeah, I'll show you. Clear this all out. I'll clear the memory too. Memory clear. Very good. How do you convert metric? Real simple. Let's 1 times 25.4 equals 25.4. Yeah. So this is, let's say, again, to do metric again, English to metric, let's say I had the decimal equivalency. I'll clear this out. Decimal equivalency of 3/8, which is 0.375, and then multiply that times 25.4. I have done this so many times on some of my calculators. The 2, the 5, and the 4 numbers on the buttons are wore off. Seriously, I'm not kidding. We hit enter, and we find that 3/8 is actually 9.525 millimeters, and that is how you say it, 9.525 millimeters. Don't say 525 thousandths of a millimeter. We don't say it that way. People look at you like you're an idiot. Don't do it. 9.525, okay? We don't want you to look like an idiot. So I was just showing you that's how we can remember. If you're going to go from English to metric, you multiply times the magic number 25.4. If you're going to go from metric to English, you divide by the magic number 25.4. All right, that's that. Replay that a couple times. We're going to do a lot of metric conversions. You're going, oh no, metric already? Yep, metric. The world is full of metric. Get used to it. Okay, we'll go ahead and minimize Mr. Calculator there. Bring this back up here so we can see it. I got it all zoomed in there. And like I said, this is all in metric. So what's the next thing we usually do, huh? Well, we're already in rapid, so let's give it a space here. I'm going to hit Control S just in case I haven't done that. See, I got this. This is applying cutter comp metric. So first I'm going to rapid again to X0, Y0. So in metric, remember 0 is this. Now, normally we would rapid to 100 thousandths above the part. Well, if you put 0.1, that's 0.1 of a millimeter, 100 thousandths of a millimeter. What is 100 thousandths of a millimeter? 0.1 divided by 25.4. Oh yeah, you're going to rapid to within 4 thousandths of the top of the part. Your operators will absolutely have a heart attack. Everything has to be converted to metric. I know what that is. It's 2.54. Really, Randall? Yeah, it won't hurt you to do another metric conversion, will you? So 0.1 times 25.4 equals 2.54. Oh my God, there's order to the universe. Control S. Yeah, that's what you want. So we're going to go to X0, Y0, and Z 2.54, which is actually 100 thousandths above the part. You're going, why did you take English and then convert it to metric? By God, if you check out a bunch of metric prints and you start converting them, you'll find out they're all English. Then somebody converted them back to metric, and then you have to convert them back to English. Yes, welcome to the world that we live in. And there's even prints that have metric and English dimensions on them, what they call those dual dimension prints. Gotta love them. Coming out of Asia. Thank you, Asia. And I'm just going to stop right there. Okay, let's go to the next line. So we rapided to there. Now, what do we want to do? What we want to do now is we're 100 thousandths above the part. We got the spindle running. I think I forgot to turn the coolant on. I don't want to do that. There are manual coolant buttons on the control. You can turn the coolant on and off manually, but it's just best to have that in there, Control S. Remember, MO8, coolant on. That looks good. All right. Now we're going to figure out what our safe start spot is. And what the safe start means is where we have to go, okay, to start our cover comp. When we talk about cutter comp, cutter diameter compensation, or some people refer to it as cutter radius compensation, that's really what it is, or other people will just call it cutter comp. Now, I don't know what they call it in different countries. That's that. I can't help you in, I can't tell you what it is in Hindi. I can't tell you what it is Mandarin. I could probably come up with a German translation, but I don't, it's not appropriate for this class. Remember, where I'm just teaching to a Midwestern audience here. Okay, so to apply or turn cutter comp on, and I'm going to keep saying turn cutter comp on, we have to make a move that is equal to or greater than the radius of the cutter we are using. Okay, I'm going to say that again. We have to make a move that is equal to or greater than the radius. Greater is better than equal to. There'll be some less sophisticated controls that if you put in like exactly, let's say you're using a 10 millimeter end mill and you put in a move of 5 millimeters, it'll error out. They will error out. So just add something. I usually add 50 thousandths. I'll show you how to do that here. Now, since this is our X0, Y0, and Z0 is always going to be on top of the part, okay, here's the top of the part. Sorry, I'm looking for the right there, Z0, top of the part. What we're going to do is we're going to start here, and I'm going to comp down here. This is where I'm going to start my comp. This is where the end mill is going to go. So let's see, half of 11, well, 5.5, right? If we made it 6 millimeters, let's make sure. That's half a millimeter is 11 thousandths. That ought to work just fine. Usually I use 50 thousandths, but you'd have to add that all up. The bottom line is it needs to be bigger than the radius of the end mill you're using. Let me just see what 50 thousandths is. Don't have that one memorized. Won't hurt you again. 50 times 25.4 equals that's 1.27. So add that to what the radius of the cutter was. What was it? Anybody? I hope you said 5.5 because that's half of 11, isn't it? Last time I checked it was. So 6.77 millimeters. What? Yeah, that is going to be a different, that's where we're going to make our safe start point. So while I rapided to here first just to make sure that I set my X0 and Y0 up, that's going to tell you, this is only going to show you if you made a big mistake. If you made a small mistake, it won't show you. You can put, as I said before, this character right here, turn on the block skip button, and it won't make that move. If you do that, anything that's after this, the computer just ignores. Okay? Then you can hit the block skip button and turn it back off, and then it does it. So a lot of people do that for setup purposes. All right, so here we're still in rapid, right? Rapid is still modal going on. All right, so we're going to rapid 2. Here's where you're going to go. X is going to be minus, that was 6.77. Boy, I should have kept that in my mind. I hope I didn't clear it out. Now let's try it again. 25.4 times 50 equals this, 1.27 millimeters plus 5.5, did it twice, 46.77. Okay, so I'm going to just minimize that so I don't remember it. 6.77. Why minus? Because remember, or what is the reason I am using a minus symbol? Is because I'm on this side. Remember, anything on this side X0 is minus. Anything on this side is X plus. Anything on this side of Y0 is plus move. Anything on this side of Y0 is a negative move. Anything here, Z0 is on the top. So anything here, anything above it, this is be a Z positive move. Anything below it, a Z negative move. Now, there are places in Europe that they actually make 00 at the bottom of the part, and places in the United States too, so that's a whole different world. I cannot account for every single formatting. Bottom line is, let's do this too. Okay, now I'm going to call that. Hey, look at me. I'm actually doing this in the morning instead of in the afternoon, so I'm not so tired. Now, if you call 12:25 in the morning. So I'm moving to my safe start position. I'm just going to call it safe start. I'll do it since this is the first one. POSITION. Yeah, Control S if you haven't done that. Bring that back. All right, great. So we rapided to that. At this point, the machine is running. Okay, the coolant's on. I got my RPM at 794. I've got, my tool length offset called up. I rapided down to 2.54. Remember, all of this stuff has to be in metric. The only thing that doesn't have to be in metric is that. That's it. That's it. Everything else has to be in metric. Don't forget that G21 up here. Life does end, you know, as far as the CNC control is concerned, if you don't do that. Seriously, you'll get a big bad error. It'll go, what? Or you'll end up with some really ridiculous stuff. Most machines now go, they'll say something like, are you sure you want to run in metric? Or metric selected, yes, and you may have to change a setting. It's just like a check, so that they want to make sure that you know that you're actually programming in metric or English. It'll do both. All right, let's take a Z move. So we're going to do a G01. We want Z to come down. How far do we want to come down? Not realistic part. We're going to go ahead and pretend we can do this all in one pass. We could not do 25 millimeters with an 11 millimeter end mill all in one pass. No way. So, but just for this, because we're just learning, I'm going to go down 25. Now, metric feeds. Oh boy. Well, metric feeds are pretty simple, really. You just calculate up your feed like you would in English, then you convert it to metric. Huh? Yep, that's right. So let's see how many feed per tooth. Looks like a 4 thousandths feed per tooth. You can't see it, but I can. It says 4 thousandths. So 4 times 4 is 16. So 16 thousandths times my RPM, right? Let's do that. Let's clear this out. 0.01616 times my RPM, which is 794, equals 12.7 whatever inches per minute. You want to convert that to metric? Yes, you do. Yes, you do. Your feeds have to be in metric too. Times 25.4 equals. Oh my God, you're going to look at that and go, that is a huge. If somebody doesn't know this and the first time they ever seen it, I should have copied that, shouldn't I? I will copy that. Copy. Okay, don't forget the F. And then paste. Let me go back to this. Okay, first time you see this, now don't carry that out to 4 places. You know, you can put decimal points in there. You really don't need to. Oh, yes, you do. You do need a decimal point in a feed. Oh my gosh, I almost screwed that up. Always put decimal points in feed. So just round it to that. That's fine. That looks incredibly large. You're going, oh my God, he's milling at 322 inches per minute. No, I'm milling at 322 millimeters per minute. That's right, millimeters per minute. All right, that's the feed. Okay, get it right. So you can watch that a couple times. I'm not going to do that 4 or 5 times. All right. So millimeters per minute, we got the feed. We moved down 25 inches. Now we're going to apply cutter comp. Now let's talk about some different codes. There are 3 codes that are associated with cutter comp: cutter radius compensation, cutter diameter compensation. That's the last time I'm going to do that. From now on, I'm calling it cutter comp. It's just easier. A G40. G40 cancels it. G41 is cutter comp left. G42, cutter comp right. I also uploaded a really nice list of G codes. You should check those out. I would print those out for your reference. That is a very good list. Remember, not all machines use all the same G codes. The majority of them use like 98% of those on there will be the same, but then each machines do, or each controls do use machine specific G and M codes. So I can't tell you, I'm not going to program for every single machine out there. All right, so we're setting here, we're down here. Okay, what do we want? Well, first off, we always have to do this in a linear move. Now, some cutter comps can actually, some advanced and more sophisticated controls will let you comp on or apply cutter comp with a rapid move, I highly don't recommend it. One, you're moving towards the part, all right, which is not a good thing. And if you mess this up, you can just crash right into it. So do that. Just a G01. Now, I said G41 was cutter comp left and G42 was cutter comp right. Well, let's pretend my little magnifying glass here is the diameter of the cutter. We want it to move right like this. Okay, obviously I can't keep it straight. Before we were going right up the center here and not doing any good. So cutter comp, you're going to use it from now on. You have to use it. Trying to do it manually, comping manually you'll not do it. It is a pain in the rear. Do not do it. Back in the old days when I had to punch paper tapes, there was no such thing as cutter comp. That's right. We had to manually comp every damn thing we did. Oh God. I don't even know why people did it. Thank God. So much better now. So, which side of the line am I on? Well, you got to pretend, all right, that you're riding it. If we're going this way, which is the way we're going to, are you to the left of the line or the right of the line? Now, it's not what side of the line to you, but it's like this is a fence and you're on a riding lawnmower. Okay? So, you're on the left side of this fence. Over here, you'd be on the right side of the fence. Remember, here's the fence, right side, left side. So this is a cutter comp left situation. So you want to put a G41, use this format. It works every single time. Deviate from it, suffer the consequences, which will be it won't work. NC View is only a plotter. It will not show you a cutter comp. I'll be able to tell if you've applied cutter comp correctly or not by looking at your programs. Later on, if we can ever get into a face-to-face class, which I hope we can, we'll put that in there and you can watch the machine do it. There are more advanced plotting software packages out there. They cost anywhere from $275 a seat to God knows what. Predator used to be good. It ain't worth a crap now. We use NC Plot, pretty decent, $275. If you're going to do this on a regular basis, like for real work, buy NC Plot. It is a good product. It does a pretty decent job. It still doesn't do everything you want it to do. That's enough of that. So I got my G01. We're always going to do that. Cutter comp left, right? Now we have to make our move. Remember, you have to make a move. So the first thing I'm going to do is, since this is x0, y0, 0.1, 0.2, 0.3, 0.4, so we're just going to mill the square, right? Just the square. Let's comp to x0. Don't forget the decimal point. Okay? G41, x0. Now you're going, okay, what else? Well, we're going to put a D01. Now, this is going to do, what this does is when it reads this, the G41, it's going to go into the control in a place called Tool Geometry page where you will have populated the actual size of the end mill. Now, actual versus nominal. Let's say you have 11 millimeter end mill, but you've used it maybe, I don't know, 10 or 15 times. Mic it, measure it. It's not going to be 11 millimeters. Whatever it is, that's what you put in here, because this is what it's going to go here, and it's going to say, oh, this is the number I used, and it's going to do all its wonderful magical calculations. It's magic to come up with the right moves. You don't have to do it. We're just programming everything like we normally do. But if that D01 does not exist, this will not work. Okay, now, do you need to put the F in there? No, you don't, but you might as well get used to it. Remember, decimal points in all your feeds. Always, always, always. Control S if you haven't done it. Now, that just went over to X0, so I'm down here, remember? Now, that means I moved over to here. Now, it actually hasn't made a move yet. These machines have what we call look ahead. Now, the more sophisticated controls look ahead 1,000 blocks. And what they do is they make their moves. They calculate their moves based on the next move that it's going to make. So I'm going to do G01 again. This time I don't have to give it a G41. Once I've turned the G41 on, I don't have to worry about it. It's turned on. So now I'm going to move Y to 0. So what I did was, let's come down here. I was down here and went over to X. And now the machine will actually do something like that. And it'll stop right there if you did all that right. Do I need to put the feed on there? I'm not putting the feed anymore. The feed's modal. Now here's the beautiful thing about this. All right, we do not have to we don't have to add anything else. Now notice there's some other rules. There are some very important rules about cutter comp that I need to tell you. One, Z moves are made outside of the G41 and the G40. I'm going to show you that later on again, but no Z moves. If you can help it, no M codes. Now some sophisticated controls don't care, other ones will error out. They'll go, what's going on? You want cutter comp to work every time? Don't put a Z move in there. You can't. Every time you change your Z height, you have to turn cutter comp off. Change your Z height, turn it back on. Okay, that's the way it works. Sorry, but it's just life. You don't put any M codes in there if you can help it. If you do, you'll end up with an error. You go, what's wrong with this? Well, guess what's wrong with it? You put a freaking M code or something in there that it told you not to. Don't try to make a Z move. It'll just get too confused. All right, hit Control S if you haven't done that. So let's see what do we got here. We're going to space over. Yeah, we got to space over now. So I'm going to go to my point 2 up here, which is 90 millimeters. So I could, you know what? Let's optimize our program. We're already at X0. You don't have to put X0 in there. You don't. The machine is already at that position. So, but doing this just makes it harder for you. Honest to God, you don't have to do that. All we have to do is put in our next Y move. Y is 90. See, right here, 90. Yep. So Y is 90. That's it. Now, I put a 0 there just because I like to do it. It's going to move to Y90. It'll go like this. Now, if I can keep it straight, mill, 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 mill. Sorry about that. And it should stop. Now, it won't know where to stop until you tell it the next move. So, what is our next move? Oops, sorry. Delete. I've already got my numbers there. This is going to be an X move, isn't it? Yes, it is. X is going to be 100 and looks like 110. Yep, it's 100 from there to there, 110. So X is 110.0. Okay. So it'll go up and it's going to be looking ahead because it's got to know, it doesn't know where to stop until it sees that. So it's going to go like this, mill, 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 and it'll stop right there. Then, now when you run this, you'll actually see it because it'll read these numbers over here on the control, but it won't make the move till it sees this one. If you do it single block, which we'll talk, single block means it just operates one line at a time. A good way to try out your program. We'll talk about that later. Okay, so what am I going to do now? Well, I want to go to what? This is point 1, point 2, point 3. That was where we're at. We want to go to point 4, don't we? So that's Y. We're going to go back down to Y0. That's all you have to put. Control S if you haven't done that lately. See? So I got Y0. Now by setting up a program just like this where you have all your startup stuff and all your numbers ready to go saves you a ton of time. Save it as a template. Just save it as what, mil template metric or mil template English. Remember the big differences on the English or the metric is G21 stays here, and of course everything has to be in metric. Okay? Yes, everything has to be in metric. Even your feed. I'll be looking for that in your metric programs. Okay? I will. If they're not right, 0. I will give you a 0. You'll have to resubmit. Sorry, they have to be perfect. That's the way it works. I know, but it's not hey, I'm not the one that makes the rules. I'm just the one that knows what they are. All right. New line. So let's go this time. We want to go back to this point right here. So 1, 2, 3. 1, 2, 3, 4. Now we're going to go back to point 1, right? But we're actually going to go to our safe start position. Yeah, that's right. X is going to be minus 6.77. That's all you have to put. Control S if you haven't done that. Too used to hitting enter. Delete. There we go. All right. Now, this moved to my safe spot. Now what I want to do is I want to turn my cutter comp off. Now you're going, why didn't you put G01s in there, Randall? You don't have to. It's modal just like the G00 is. Unless you change it, it's there. So see, look how much easier this got. All we had to do was put in one set of coordinates. Now if we're moving at an angle like this angle right here, if we did this, we have to program it in 2 sets. But since all we're doing is going from there to there, from there to there, remember this is your first cutter comp thing and a little bit of introduction to metric. Got to hit them all at once. So yeah, I'm going to turn it off. I am going to turn it off. So let's put a G40 and then now we were at we want to go back to our y safe spot. Y minus 6.77. Control S. All right, now let me show you what I'm talking about. Between the G41 and the G40, there is nothing but coordinate moves. No M codes, no Z moves. You try to do any of that stuff in there, don't get fancy, it won't work. Now, I know Morisiki will let you do that. CAD CAM, they turn it off and on, and actually a lot of time CAD CAM actually doesn't even use cutter comp here. It'll do comp in the control, can be comp in the computer. There's just a lot of different ways to make it comp. So get what comp is. Cutter comp is that. At this point, we're back at our starting point, and I'm all turned off. I'm all turned off. All right. Now, what am I going to do? Well, there's a variety of different things. I could complete this program. All right. And I guess let's just go ahead and do it. Why not? It's not taking that long. Come down here. What I want to do is, well, I'm going to move Z up. So I'm going to rapid Z up, G00. And I'm going to do this. This is an island. See, it's an island. Yeah, island. All right. Let's see. It's 10 millimeters deep. So Z, and even though we're going up, it's still, remember, everything comes from the top. So that's Z minus 10. If you tell it to go to Z10, it's going to go 10 millimeters above the part. Go ahead and do it and watch it. Oh, that ain't going to work. That will work. Control S. All right. Now I moved it up. Now, another rule about comp is you need to comp to a place where two lines intersect. Like if you want to comp to a radius, you're going to get an error control 95% of the time. You're going, well, we do it in Mastercam or with my, with my Smart Cam or whatever. Yeah, it'll do it because it's doing it mathematically. It's not doing it through the control, people. It's not. So sometimes a lot of controls, I guarantee a HOS will not let you comp to that. So I'm going to go to this point right here. So we had 1, 2, 3, 4. What is this point right here? Well, let's see how that works. We got, looks like I got 90 minus 35 divided by 2. Yeah, that's what it is. 90 from there to there. 35 from there to there. It's centered. So 90 minus 35 divided by 2. Let's try her. Clear it out. 90 minus 35 divided by 2 equals 27.5. So that coordinate right there is going to be in Y, and that's what I come up with. Y is 27.5. Okay? And let's see. What is X? Well, X is given to us 5. So let's do this. Let's minimize that. Z's where I want. Spindle's still running, everything's good, feed's still active. So what am I going to do? Well, I'm going to go G01. Don't forget that, because that once you go from G00 to G01, you definitely have to put them in there, or it'll be stuck in G00 and you'll crash. So that was this is a good reason to write that down. X is 5 millimeters and Y is 27.5. So let's turn this on. Here we go, G01, and first off, we're always going to make this move perpendicular from our safe start spot. So X is going to be 5. Let's put our G40 in there too. I like to put it just like that. If you do it like that, this always confuses me. There we go. Okay, Control S. So G01, G40, X going to 5. Don't forget your D, D01. And, yep, probably ought to program a feed because guess what? It's a good idea. 33, 332. And don't forget that decimal point. If you do, I already showed it to you. It won't work. You need a decimal point. Remember, the only place you don't put a decimal point is in your spindle speed, okay? Everything else, just get used to it. Don't put a decimal point here or here in your G codes or your D or anything like that. That ought to get us over. So we went over to here. So remember we were down here. So now we came over to here. But it's looking for that next move. All right. I do not need to give it a G code, so I'm not. My next move is going to be Y. And what was that? 37.5? Oh, I cleared it back out. Well, let's do it again. I went 90 minus 35 equals that divided by 2. 27.5. Okay, because it's 90 from there to there. This is centered in the 90. So if I take this and subtract it from this and divide it by 2, I get the distance from there to there. We use that particular little thing all the time. So 27.5. You see, you can do this without doing a coordinates chart, and a lot of people do. I highly recommend when you first start, don't do it, or do make your coordinate chart. I am just going ahead and doing it without it, showing you that it can be done. So at that particular point, that's it. That's all we need right there. So now we went to here. Okay. Now you're going, well, why did, you know? So we went over and we went up. Now I fed because I needed to get to that point. So I fed from my safe start. So it went, I could bump this feed up if I wanted to a little bit. If this were making like 100,000 of these parts, I would run this probably 4 times that. But I'm not. All right, I'm not. So we won't do it like that. Now we want to go to this point right here. So all we have to do is enter again. We're moving a y. It's a y move. So let's put y there. And what is that? Well, this was 27.5 in y plus 35. See, look how I do it. 27.5, which was already there, plus 35 equals 62.5. So I'm going to go to y 62.5. Control S if you haven't done it. Yep. All right. Now I'm going to skip this radius because bottom line is this is a part we're going to use later on. I'm not going to program the whole thing right here. That would be crazy. All right. So we're just going to go ahead and go from there to there, from there, there. We'll skip the radius. If you don't like it, that's the way it's going to be. So I'm right here. All right. Now I want to go to here. All right. So that's going to be an X and a Y move. Remember, you're going to move both axes at the same time. So X is going to be, well, let's take a look. Again, look what we got, 55 from there to there and 110. It's the same thing that we just did, and that's what this is all about. Clear that out. 110, you got to love metric because most of the time there's just no fractional equivalence. So it's easy. You don't have to worry about fractions in metric. 110. And I'm going to minus, subtract 55 equals this. And of course, divide that by 2, 27.5. Now that is one heck of a coincidence. Makes me think I did it wrong. Let me try it again. So I got 110, 110, okay, minus 55 equals this, divided by 2 equals 27.5. So X is going to be 27.5. That looks funny, X. Did I? X, yep. You'll make the same mistakes. It is really hard to remember that you have to work in all caps. You do. You really do. So Y. What's my Y move? Well, this time we moved over here to Y, so I got 80, right, from there to there, and it looks like it's 5 millimeters from there to there, so that's 85, isn't it? Don't forget your decimal point, please. If you don't, like I said, this is what the machine will see. If you don't put that decimal point in here, I'm going to clear this. You put 85 like this in here, no decimal point, this is what the machine will see. You ready? Yep. And you're going, why is that? Well, I'll tell you the history lesson later on. Most people don't like to hear that much stuff anyway. Trust me. Use the decimal point. All right. It's a throwback from the way we have. All right, real quick. This is the way we used to have to program it. Let's say I wanted to program 625 thousandths. Here's the way you put it in. What is? Oh, this thing won't populate zeros. Oh, never mind. I did not know it wouldn't do that unless there was a number in front of it. So what do you know? All right, so let's go. We're right here. That's fine. New line. Oh, oh. This time we're just moving the x-axis, right? X. Now x is going to go to, let's see, this point right here. Remember, we're not going to do the radius. I'm just going to go right here. Another, so x is going to be, let's see. Well, this time we got what? Look at it. We can come up with that point right there. Again, it's going to be, let me see, 110. So I know it's 27.5 from there to there. Okay, right? Because it was 27.5 from here to there, and this is centered, so it's 27.5 from there to there. So I guess all I have to do is just take 110 and minus 27.5. 110 minus 27.5 equals 82.5. So I'm going to move the x to 82.5. Notice I am putting in the actual dimensions. Once you turn the comp on, you're fine. Now, I'm not using, that's it. New line. Control S. Now I'm going to make an X and a Y move. X, I know what the Y is because it's exactly the same as this one over here was. X though, let's see. Well, how are we going to come up with the X? Well, we know it's 100 from there to there plus 5. It's 105. 5 millimeters from there to there plus 100 from there to there. That's 105. So X is 105. Point. You can put a 0 in there if you want to. And Y, it's going to be exactly the same Y as this one over here was. So what was that one? Was it 62.5? Well, it surely wasn't 82.5. No, it's 62.5. So, see, this is another reason for you to put your coordinates on your coordinate sheet and give you a reason why to do it. You don't have to. And folks, all I really need you to submit is this. A lot of people were submitting setup sheets and stuff like that. You don't have to do that, people. On the online course, just send me the program. Okay, that's all I need. Hit Control S, new line. So we're right here. Okay, I'm not even going to go points anymore. Dang, I keep opening that because I got the numbers already formatted. Keep forgetting. This time I'm going to what? Right down again. So I'm moving Y. Notice I'm only programming in the axes that I need. Well, we knew what that was too. That's Y is what? 27.5. Okay, very good. New line. Oh, dang it, quit that. Stupid me. Delete. This time we're going to move another X and Y move. So X, it's the same as it was up here. It's right in line with it. So what was that? I'm going to say that was X 82.5. Y is going to be, well, looks like 5. It's 5 up, so Y is 5. Again, please do not forget your decimal points. It takes forever to find that. That's an error that you'll go, oh, what's wrong with this? Control S if you haven't done it. Okay, so I'm right here. We're going to go over to here, so I'm just moving the x-axis. You know, I've already got all my coordinates picked up now. What was it? It's the same as this one over here. So what was that one? Well, I think it was x 27.5. Yep, x 27.5. Once you get good at this, Control S, okay? So now we're right here. Remember, we're not doing the radiuses. I'm not doing it for this example. This is just how to turn cutter comp on. Okay, now, what am I going to do here at this particular point? All right, X is 27.5, and let me see. So, X is 27.5. That's right there. Okay, so we did move from there to there. Okay, new line. So this time I want to do this angle, which this means I'm going to move both X. X is going to be 5, and Y is going to be, I believe, 27.5. I know I am right. That is correct. Now, I'm not going to, again, I'm not programming realistic. We would actually have to extend this because it's going to stop right there, which is going to leave a little scallop. It's going to leave a little divot right here, scallop, divot. There'll be some stock there. So what we'd have to do is later on we'd have to trig a point out here to go to. All right, that's just all there's to it. Here, see, I forget every time you click on this sucker, it's because I'm still in Zoom. Let's go out of Zoom. I hit escape and we'll go out of Zoom. I wish I could get the arrow. Bottom line is we'd need to go continue on out to clear that cutter, or we're going to end up with a little scallop there. We're not doing it. I'm just showing you how to turn cutter comp on and off. What do we do at this time? Well, this is pretty simple. We'll just do the same thing. We're going to do a G40 to turn it off because we've done it. We've finished our part. G40. X is going to go to its safe spot, which was minus, let me see, this is why we go up here and look, 6 points. I got 2 points up here. That is an error. Told you it's hard to catch. X is going to be minus 6.77, 6.77, and do that. New line, Control S. This time now we're just gonna, excuse me, that G40 doesn't go there. Okay, I want that G40 in the Y move. Because what you're going to do is you're going to come up and go over. Now this time you don't have to go back to your safe spot. You just have to make a move that is greater, okay, than the radius of your cutter. So G40, turn it off. And I'm already at, let me see, I'm at Y27.5. If I went to like Y, I'm off the part. So if I went to Y, what? You I need at least 6.77. If I went to Y20, that's 7.5 millimeters. That would be fine. So let's do that. I'll just go to Y20. Okay. And that will turn the comp off. Okay, now I have to do this. All right. At this particular point, we're ready to go ahead and end this up. G28. And don't put in Z 4.0 because that ain't right. Remember metric. So 4 times 25.4. That's what 4 millimeters equals. 101. 4 inches, excuse me, is 101.6 millimeters. So Z 101.6, 101.6. Control S. Next thing we're going to do here is we're going to give it the good old M30. And remember what the G28 does. One more time, the G28 is going to send the machine home as fast as it can go. But first, it'll move this Z will move up 101.6 millimeters above the top of the part. Then all axes will go home and recalibrate themselves. M30 says simply end of program, and then don't forget a percentage sign. Now, a word about this real quick here. You can't have any block numbers after this. So you're going to go, what? Yeah. So here's how you do this. Just go and wiggle it, wiggle it, wiggle it, get all the way down here. Look, there's the percent sign. Hit delete. Okay. Now, and then delete. If you try to put a percent sign on a block number, there's a lot of machines will error out. Control S if you haven't. That's it. So let's go over the basic rules. First off, G40 cancels it. You always have to turn it on with a move that is greater than the radius of the cutter. I use a 50 thousandths radius. 50 thousandths radius, not gradius. Funny. Anyway, that's some Latin guy. All right. Sounds like a gladiator. Gradius. Hordi, which means whatever it means. Hordi means barley eater. All right. Let's go ahead. This is, yep, go back to that. G40 turns it off. G41's cutter comp right, left. G42 is cutter comp right. We'll do more cutter comp rights. Okay. But remember, we're always going to climb mill, which means we're always going to mill in the direction of cutter rotation. We want the cutter going like this. Let's see if I can get my, I wish they'd have a little dot or something, but they don't. PDF files are what they are. Bottom line is that should work good for you. All right, I'm hungry. I got things to do, other stuff to do, so have a good one. I will also do, I've got another one where it does a square in English and tells you all the same stuff that I showed you here. Just watch this one first, which I'm going to put that on there. All right.